In the heart of the Islamic Golden Age, a brilliant mind laid the foundation of modern mathematics. His name was Al-Khwarizmi, the man who gave us algebra, algorithms, and a new way to think about numbers. Muhammad ibn Musa al-Khwarizmi. Let's start with his full name. It reflects the cosmopolitan nature of his time. Muhammad, a common Arabic name, indicates his Muslim faith. Ibn Musa signifies his lineage, tracing back to his father, Musa, and Al-Khwarizmi pinpoints his origin. But why is it pronounced that way? Well, when his works were translated into Latin, his original Persian name got a Roman makeover. So, while we honor him today as Al-Khwarizmi, the original pronunciation might have been closer to something like Khwarizmi or Khwarizmi. Now let's set the stage. Born around 780 AD in a place called Khwarazm, located in what is now Uzbekistan, Al-Khwarizmi's birthplace was a hub of trade and cultural exchange along the ancient Silk Road. Sadly, details about his early life are scarce, but we do know that he embraced Islam and that his journey led him to Baghdad, the capital of the Abbasid Caliphate. Here's where things get really interesting. Around 813 AD, he arrived at the House of Wisdom, also known as Dar al-Hekmah, a remarkable institution that served as a palace library, a translation center, and a hub for scholars from across the known world. Imagine a place where the works of Greek philosophers met with Indian astronomy and Persian poetry. That was the House of Wisdom. Fast forward to the 9th century, and Baghdad had evolved into a cosmopolitan city with a thriving intellectual scene. Influenced by the Hellenistic world, Persian traditions, and Indian scholarship, the city was a melting pot of ideas. Enter the House of Wisdom, a beacon of knowledge established by Abbasid caliphs Harun al-Rashid and his son Al-Mun ibn Harun. Situated within the royal palace complex, it was more than just a library. It was a hub where scholars gathered to translate, discuss, and build upon the works of various civilizations. When Al-Khwarizmi joined the House of Wisdom, he found himself in the midst of a vibrant community that prized intellectual pursuits. Under the patronage of the caliphs, this institution fostered an environment of learning and research that would become a hallmark of Islamic scholarship. As Al-Khwarizmi immersed himself in the wealth of knowledge at the House of Wisdom, he likely interacted with scholars from diverse backgrounds. They shared ideas, debated concepts, and delved into the intricacies of various disciplines, fostering an atmosphere of intellectual exploration. This multicultural setting provided Al-Khwarizmi with a rich and varied learning experience that would shape his contributions to mathematics, and it was here that the course of mathematical history was set to change. During his time at the House of Wisdom, Al-Khwarizmi embarked on a groundbreaking journey of discovery that would forever alter our relationship with numbers. His masterpiece, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, often referred to in English as the compendium book on calculation by completion and balancing, stands a testament to his genius. Published in 833 AD, this book wasn't just a collection of mathematical ideas, it was a revolution. Before Al-Khwarizmi, mathematics was largely viewed as a collection of rules for practical applications, useful but not necessarily profound. However, with his introduction of systematic methods for solving linear and quadratic equations, mathematics took on a new dimension. The very structure of his book was revolutionary. Instead of presenting solutions to individual problems, a common approach at the time, Al-Khwarizmi demonstrated step-by-step procedures for tackling entire classes of problems. This systematic approach laid the foundation for modern algebra, transforming mathematics from a set of isolated techniques into a universal language of problem-solving. Let's break down some of his key contributions. First and foremost, Al-Khwarizmi's work introduced the concepts of Al-Jabr and Al-Muqabala, which gave rise to the modern term algebra. These terms referred to two fundamental operations used in solving equations, namely balancing or restoring and completing or adjusting. By applying these principles, one could systematically solve linear and quadratic equations. Second, he provided a geometric interpretation of numbers. laying the groundwork for abstract algebra. This approach allowed for a deeper understanding of algebraic concepts by visualizing them in geometric terms. For instance, he illustrated the solution of an equation at the point where two geometric figures intersect, thereby providing a clear representation of the answer. Third, Al-Khwarizmi employed a systematic demonstration method, a precursor to mathematical proof, ensuring the validity of his solutions. This method involved logical deduction, a departure from the empirical or intuitive approaches prevalent at the time. By demonstrating the correctness of his procedures, he laid the groundwork for rigorous mathematical reasoning. Fourth, he developed algorithms for specific calculation methods, a significant step towards the modern concept of algorithms. These step-by-step procedures for calculations, such as finding the area of a triangle or the volume of a sphere, were not only efficient, but also laid the groundwork for the algorithmic thinking that underpins computer science. Beyond his contributions to algebra, Al-Khwarizmi's influence extended to other areas of mathematics. He made significant strides in geometry, number theory, and arithmetic. His work on arithmetic included a compilation of rules for Hindu Arabic numerals, a numbering system that eventually replaced Roman numerals. This compilation, known as preserved in Latin as Compendium Book on Calculation by Completion and Balancing, played a crucial role in disseminating the use of Arabic numerals throughout the medieval world. These numerals, with their symbols and place value system, offered a more efficient and intuitive way to represent numbers, revolutionizing arithmetic and paving the way for advanced mathematical studies. Furthermore, Al-Khwarizmi's contributions to geography and astronomy were equally groundbreaking. In astronomy, he refined astronomical tables based on the works of Greek astronomers like Ptolemy, providing valuable data for measuring time and determining the movements of celestial bodies. These tables, used widely across the Islamic world and beyond, contributed to the accuracy of astronomical calculations for centuries. In geography, Al-Khwarizmi authored the Kitab al-Surat al-Ard, translated as Image of the Earth, a significant work that discussed the Earth's size and shape. He provided a method for determining the circumference of the Earth, a departure from the prevailing belief in an infinite ocean that separated the known world. By using geometry and measurement, Al-Khwarizmi helped establish a more accurate understanding of the Earth's dimensions. But perhaps Al-Khwarizmi's most enduring legacy lies in the concept of the algorithm, a term derived from the Latin translation of his name, algorithmi. The algorithm refers to a step-by-step procedure for solving a problem or accomplishing a task, forming the basis of problem-solving in mathematics and computer science. His work laid the foundation for the systematic and logical approach to problem-solving that is at the heart of modern algorithms. While Al-Khwarizmi's contributions were recognized during his lifetime, his influence truly took off after his death. In the 12th century, his works were translated into Latin and introduced to European scholars through the efforts of figures like Gerard of Cremona. This exposure marked the beginning of a new chapter in the reception of Al-Khwarizmi's ideas. During the Renaissance, European scholars rediscovered the brilliance of Al-Khwarizmi. His systematic approach to algebra and the introduction of algorithms sparked a renewed interest in mathematics and science. Figures like Fibonacci, Niccolo di Niccoli, and Luca Pacioli studied and popularized his works, laying the groundwork for the scientific revolution that would transform European thought. The impact of Al-Khwarizmi's ideas on the course of Western mathematics was profound. His emphasis on logic, systematic demonstration, and the use of algorithms paved the way for the development of modern mathematical thinking. Sadly, despite his monumental contributions, much of Al-Khwarizmi's work remained unknown in his own country for centuries. Only in recent times has there been a revival of interest in his life and legacy within Uzbekistan and the broader Muslim world. Al-Khwarizmi's genius transcended time and geography. His ideas, initially nurtured in the cosmopolitan atmosphere of Baghdad, resonated across cultures, laying the foundation for modern mathematics and science. From algebra to algorithms, His contributions continue to shape how we understand and interact with the world. Al-Khwarizmi's story reminds us that intellectual brilliance knows no bounds, and that curiosity, combined with a systematic approach, can unlock the secrets of the universe. His legacy serves as an inspiration for generations of scholars and a testament to the power of human curiosity. Thank you for joining us on this journey through time to discover the extraordinary life and contributions of Al-Khwarizmi. If you enjoyed this video, don't forget to hit the like button and subscribe for more fascinating stories from history. We've got plenty more where this came from. Thanks for watching.